No, we're not doing it at all. Okay, so come right here. You guys open up to here. Okay.
Wait, can I still get my review after I do the test?
No.
Interesting. Okay, then I'll take it tomorrow.
Okay. But you can work on a review. We'll have lots of homework time today. The lesson is short, so, and I think it's pretty easy. Okay, so what we're learning this unit, our last unit of the year, is called trigonometry. The word ometry means like the study of, and trig is like triangle. Last unit, we learned about similar triangles. So we had two triangles, and we learned how the two triangles compared to each other, right? This unit, we're looking at one single triangle, and we're talking about how do the angles and the sides inside the triangle compare to each other. Of all the things we learned, this is actually the most like applicable. Like if you're building a staircase and you want to figure out what angle to like make your wooden pieces, and you know like how tall you want the staircase and you know how much space you have, that's what this kind of stuff is used for. I've had students come back and they had me help them with some measurements using trig because they were fabricating like handlebars for a motorcycle that they were working on and things like that. So this stuff is actually pretty useful, and a lot of you will end up using this more than what you think, especially if you go into like a trade. My boyfriend is a plumber, and he uses this stuff all the time to figure out how to get the pipes to fit in certain spaces and things. So now trig specifically is just about right triangles. Does anyone here remember what a right triangle is? What is a right triangle? Evan?
90 degrees.
Yeah, one of the angles is 90 degrees, has to be, okay? So a trigonometric ratio, I know that's a big fancy word, but what that is, the word ratio means fraction, okay? So it's a trig ratio is fractions comparing parts in a right triangle. So comparing one of the sides and an angle and things like that, okay? The hypotenuse in a right triangle, anybody remember what that is? What's the hypotenuse? Anybody remember? I know it's probably been a while. What's the hypotenuse of a right triangle?
Are we skipping referencing?
We're going to come back to that. Hypotenuse. Anybody remember? It's okay. Think about it. Dig back in your math memory. Hypotenuse. That's a good guess. Yeah. Hypotenuse.
All the angles added up?
No, that's 180. Come on, guys. I know you can get it. Dig back in your math brains. What's the hypotenuse?
Two angles that are the same.
No.
I'm going to keep guessing.
Yep, Zaxon?
Is it the biggest side?
The longest side. The hypotenuse of a right triangle is the longest side.
I was getting close.
Yeah. So here, my hypotenuse, it's always on the exact opposite side of the 90-degree angle, okay? The hypotenuse is always the longest side, and it's always the exact opposite of the 90-degree angle, okay? So far, okay? Okay? So the issue with deciding opposite and adjacent, so I've got two more sides. Now, opposite means across, and adjacent means right next to. Well, the problem is that across from what? Right next to what? Okay? So this is where we need a reference angle. You know how normally our random variable we use is x, right? We just always just use x, right? Well, for angles, we have another random variable we always use. It's called theta. It's a Greek letter. And it's like x, we just always use it for angles, okay? So to figure out which of the side lengths is opposite or adjacent, I have to decide which of my angles I'm going to refer to. That's called our reference angle, okay? So if I were going to make this angle my theta, okay? Then the two side lengths I haven't labeled yet, one of them is adjacent or right next to theta.
It's supposed to be like 8-ish.
Kind of like a circle with a line through it. Okay, so one of them is adjacent or right next to theta, and one of them is opposite or across from theta. Okay? So this one, the vertical line, is that one adjacent to theta or across from theta? Yeah, so this is one we would call our adjacent side. And then this third side would be our opposite side. Now notice if I had moved theta here instead, my hypotenuse wouldn't have changed, right? But my opposite and adjacent would have switched. So that's what the reference angle is. It's which of the angles besides the 90 that I'm referring to, okay? So let's look at example 1, okay? Based on the theta that they've given, is this side here, look at the one I'm pointing to here, is that opposite, adjacent, or hypotenuse? Remember, we're referring to where the theta's marked.
Jason?
Good. Why isn't it hypotenuse? Yeah, I think this is easier to label them if you label your hypotenuse first and get it out of the way. Does that make sense? Okay, so then that leaves this one as our opposite side. Try the next two. Okay, you don't have to write out the whole words. You can write just HOA or the 3 letters there that I have. Try the next two.